You face a number that looks impossible. Minus 128.6 degrees Fahrenheit. Air that freezes skin in seconds. A place where metal snaps. A place where breath turns solid. This is the coldest temperature ever recorded on Earth. You are watching HEH. In July 1983, the Soviet research station Vostok logged a reading that stunned every scientist who worked in polar research. The instruments at the station showed minus 128.6 degrees Fahrenheit. That is minus 89.2 degrees Celsius. The reading came from the heart of Antarctica, a continent that holds the lowest temperatures measured on the planet. You need context to understand how extreme this number is. At 0 degrees Fahrenheit, exposed skin feels pain. At minus 40 degrees Fahrenheit, lungs struggle. At minus 70 degrees Fahrenheit, frostbite strikes in 1 minute. At minus 100 degrees Fahrenheit, equipment fails. At minus 128.6 degrees Fahrenheit, the atmosphere becomes hostile to life in a way no human body can survive without heavy protection. Vostok Station sits near the South Geomagnetic Pole. The altitude is high. The elevation stands at about 11,400 feet. Thin air traps less heat. Antarctica receives little sunlight, and during winter, darkness lasts months. The combination creates a perfect cold sink. The ground near Vostok rests on ice more than 2 miles deep. Pressure inside this ice sheet forms Lake Vostok, a hidden lake that stayed sealed off from the atmosphere for millions of years. The water sits under intense pressure and remains liquid because geothermal heat rises from below. Above the lake, the surface receives almost no warming. The cold pools and stays trapped in a large depression. These conditions made Vostok Station the ideal place to record Earth's lowest temperature. The team at Vostok used precise thermometers placed in well-protected housings. The reading came during a long polar night. No sunlight reached the station. Winds were low, which allowed cold air to settle. The sky was completely clear. Clear skies allow heat to escape into space. Clouds trap infrared radiation. Without clouds, the ground radiates heat upward until it reaches its minimum temperature. Most Americans know Antarctica as a frozen wilderness. Few know how much data the United States collects from the continent. NASA uses satellites such as MODIS and Landsat to track the coldest air patterns. After 1983, satellite sensors recorded surface temperatures near minus 133 degrees Fahrenheit in a ridge on the East Antarctic Plateau. These sensors capture the infrared radiation emitted from the ice sheet. The readings refer to surface temperatures, not temperatures measured by ground equipment. Ground measurements follow strict standards. For this reason, the 1983 Vostok reading remains the official coldest temperature ever recorded. You see why the number matters. It represents the lower limit of Earth's climate system. Scientists use these extremes to test climate models. When a model can recreate both the hottest and coldest extremes, it shows accuracy. The United States National Snow and Ice Data Center often uses the Vostok record to explain how Antarctica stores most of Earth as freshwater ice. That ice influences sea levels. If enough ice melts, coastal cities in the United States face higher risks. Miami, New York City, and New Orleans monitor these trends closely. Antarctica's cold core affects global patterns. Understanding its extremes helps predict future climate behavior. Life at Vostok Station is hard. Crews rotate through short missions. Temperatures stay below zero for most of the year. Supplies come by long tractor trains that crawl across the ice. Vehicles run slowly. Engines require constant heating. Fuel becomes thick. Tools crack. Plastic becomes brittle. Breathing cold air directly can cause ice to form inside the nose and throat. Researchers at the station wear multiple layers of insulated clothing. The gear includes heavy jackets, thermal pants, inner layers, face masks, thick gloves, and boots rated for temperatures far below anything in the lower 48 states. Even at this level of protection, workers limit exposure. Equipment checks require speed and efficiency. No one stays outside longer than necessary. In the United States, the coldest temperature recorded happened at Prospect Creek, Alaska. The reading reached minus 80 degrees Fahrenheit in January 1971. This number still feels extreme, but it stands far above the Vostok record. Alaska receives sunlight even in winter. It sits at a lower elevation. It has ocean influence. Antarctica has none of that. The continent isolates itself from warmer air with a strong band of winds called the Antarctic Circumpolar Current. The coldest temperatures in Antarctica come from radiative cooling. Radiative cooling happens when a surface loses heat to space. On clear nights, the loss increases. On the East Antarctic Plateau, the dry air contains almost no moisture. Water vapor traps heat, so low moisture means low heat retention. With almost no incoming sunlight during polar winter, the surface cools constantly. Scientists also track the thermal inversion. A thermal inversion happens when air near the ground becomes colder than air above it. On the plateau, cold air sinks into low points. This creates stable layers of frigid air that stay in place. Vostok Station sits in one of these areas. You can imagine the data logs from 1983. The temperature dropped slowly through July. Each day showed readings far below anything seen in the rest of the world. When the instruments recorded minus 128.6 degrees Fahrenheit, the team confirmed the number. Redundancy checks followed. They used multiple sensors. They reviewed calibration. The record stood as verified. The United States scientific community studied the data closely. Researchers wanted to understand how clear sky conditions, altitude, and ice sheet structure created this extreme low. The findings helped build better climate models. These models now forecast future polar temperature changes with higher accuracy. That accuracy matters for agriculture, energy planning, water management, and coastal development across the United States. During the past decade, satellite readings identified several pockets in East Antarctica capable of reaching lower temperatures than Vostok. These pockets exist in high ridges. The cold forms during brief periods of clear sky and calm wind. The readings do not count as official records because they come from remote sensing rather than ground instruments. Vostok remains unmatched in verified numbers. The station represents the ultimate test for humans living in cold environments. American research stations like Amundsen Scott's South Pole Station experience extreme cold too, often reaching minus 100 degrees Fahrenheit. Yet even there, the coldest readings remain warmer than Vostok's 1983 record. Cold affects materials in predictable ways. At minus 128.6 degrees Fahrenheit, rubber stiffens. Grease turns solid. Batteries fail. Batteries rely on chemical reactions that slow at low temperatures. In such extreme conditions, even electronics need heating elements, metal contracts. Steel becomes prone to breaking under stress. Thermal stress affects tools and machinery. Crew members working outside need to consider these factors during every task. You can study this record from a physics angle. Heat transfers from warm objects to cold ones. In an environment this cold, human bodies lose heat rapidly. The process follows basic thermodynamics. Insulation slows the loss, but never stops it. The only true option is to limit exposure and use powered heaters. Antarctica also lacks humidity. Dry air pulls moisture from skin and lungs. You need frequent hydration. You need to protect your face and hands with full coverage. Frostbite can happen in minutes. In Vostok conditions, it happens even faster. Most Americans will never experience anything close to these temperatures. The coldest spots in the continental United States, such as Montana or North Dakota, record winter lows around -40 degrees Fahrenheit during severe cold snaps. That number feels harsh. Compared to Vostok, it reads like mild weather. Scientists view the coldest temperature ever recorded as a key part of Earth's climate history. The record shows the limits of natural cooling. It tells you how far temperatures can fall on a frozen continent with specific conditions. It also serves as a benchmark for future research. Climate trends show warming across Antarctica, but the interior remains cold. Warming happens faster near the coast. The East Antarctic Plateau changes slowly because it sits far from ocean influence. Yet even slight warming affects ice behavior. If the plateau warms by a few degrees over centuries, ice flow into the ocean may shift. Such changes matter to the United States, where millions live in coastal regions. The Vostok record keeps scientists grounded. It shows how varied Earth's climate can be. It reminds researchers that climate is not uniform. Some areas warm, some remain stable. Some cool temporarily due to natural cycles. The record also proves the need for long-term monitoring. Without decades of observations, climate models would miss key details. The record also inspires public interest. People follow stories about extreme weather. Americans in northern states compare their own winter experiences to Antarctic data. Schools use the Vostok record in science lessons. Television networks feature the station in documentaries about survival. The coldest temperature ever recorded highlights human resilience. Researchers at Vostok faced isolation, limited communication, and harsh conditions. They collected data with care and precision. Their work became part of scientific history. Their readings changed how we understand polar climates. You also see the role of global cooperation. Multiple nations operate research stations across Antarctica. They share information. They follow the Antarctic Treaty, which keeps the continent free of military conflict and focused on science. The United States, Russia, and many other countries support climate research there. The 1983 Vostok reading remains unmatched. -128.6 degrees Fahrenheit sits at the edge of what Earth can produce naturally. The reading describes a world with no warmth, no sunlight, and no relief. It describes an environment shaped by altitude, ice depth, clear skies, isolation, and extreme dryness. When you explore this number, you understand the roles of physics, geography, and climate. You see the relationships between sunlight, ice, elevation, and atmospheric moisture. You see how delicate and complex Earth's climate system is. The coldest temperature ever recorded represents a benchmark that helps guide modern climate science. It shows you what the planet can do at its most extreme. It also gives you a clear image of the challenges researchers face in Antarctica. This story keeps growing. Satellites keep scanning the plateau. New instruments keep collecting data. American scientists continue to study the ice sheet. The record survives because of accurate measurement and careful verification. It stays in the record books as a reminder of the planet's ability to create conditions beyond normal human experience. The number remains the reference point for any discussion about cold on Earth. Minus 128.6 degrees Fahrenheit stands alone. This topic opens the door to deeper exploration of how extreme environments shape scientific research.